Composition of functions. If you talk to other people who've taken college algebra, you'll always hear them talk about the Fogg-Goff method. Those are simple descriptions of what we're doing here. What is a composition? Or when something is a composite, what does that mean? Of what? Put together with what? If something's a composite, which I think is there's construction, that's put together. A composite is it being put together with multiple parts, multiple things. Fiberglass and say concrete, if you want something to be indestructible, or Kevlar and cloth, if you want a bulletproof jacket. That's a composite. We have two things, multiple things put together to form one entity. So what these are in mathematics functions within functions. How would you read that? We talked about functions already. How would you read that? Yeah. Function f of x. Because what if I gave you g of x? You can't say function of x. It's the function. This is the name of the function. This is the variable used in the function. So we just commonly call it the name f of x, g of x. That's what it's like. So whatever's inside here is you plug it inside the variable in your equation. So for example, if I gave you this, g of x is described as 3x plus 2. The way you would read this one is g of 3. G is the function name, of is my variable, what? Of 3. In place of x, I'm put a 3. So anywhere I see an x, I put a 3. Then I work it out. So there's my answer. G of 3 is 11. Which means that we have a point in our graph at 311. All right. So that's what we did in chapter 2. When we first started about functions. Now, a composition of function means a function within a function. The way you would read this, that's why it's called the Fogg method, but it says f of g of x. F of g of x. It's the function f, that's the outer one. It's made up of what? It's made up of g, which is made up of x. So that's the way you would interpret it. And the Goff method, g of f. This is read g of f of x. So the outer function is g. This is the outer of f, the inner function of the variable. of x.
So why are we bringing?
Because we'll need that to prove existence of what we're going to talk about next, of inverse functions. So a function within a function, that's what this is all about. We'll get to why we're doing this in a second. So let's look how we would do these type of problems. So let's say f of x is 3x plus 2, and g of x is x plus 1 over 3. Nope, g is x. So what this one says, it's f of g of x, which is the outer function's f, the inner function's g of the variable x. Now, how would you interpret this? Right, so we take the equation of g and put it inside the x values of it in the f function. So what this one says is take the equation of g, anywhere we see an x in the first one, plug that in there. That's what this one says. My f function is the outer one. And so anywhere I see x inside that one, I put g. This is my 3 times x plus 2. The 3's cancel, so I have x plus 1 plus 2. So my value for f of g of x is x plus 3. As you simplify as far as you can go. That's how this thing works. We can go the other way also. G of f of x. So it's g of f of x. So what this thing says is I take the function f, the equation of f, and put it in place of x of the g. So I take this equation here. Anywhere I see an x inside the g of x, I put it in its place. So what this one says is I have 3x plus 2, that's the x value of my g function, plus 1 over 3. And then just simplify. I don't need the parentheses on top. So I have 3x plus 2 plus 1. Combine like terms, 2 plus 1 is 3. On the top, they both have a 3, so we can factor out a 3, which gives us x plus 1 divided by 3. Since we factored out the 3, we can cancel that with the denominator. So our answer is x plus 1. That's how this thing works. And we're not just stuck with g of f, f of g. We can make g of g or f of f. We can make the same function inside itself. So let's look at with the same functions we have defined. So we have f of x is equal to 3x plus 2, and g of x equals x plus 1. We're going to do what's called FOF, f of f. Of x. So what does that mean? That means we take this equation, which is our f of x function, put that in place of x. So there's the 3. X is going to be 3x plus 2, and there's the plus 2. So that's how the FOF works. Take the function itself and plug it itself back inside where we see an x. 3 times 3 is 9x. 3 times 2 is 6. Combine like terms. So our FOF is 9x plus 8. And the last one, we'll do GOG. What this one says is we take the function g of x and put it back in place of x inside the function g of x. Remember, g of x is x plus 1 over 3. So what this is telling me to do is anywhere I see an x, I put the function g of x. Anywhere I see an x, I put the g of x. Well, what is g of x? G of x is that whole equation there. So that's g of x, then plus 1 over 3. So you can put a function back inside itself. In order to complete this, we have to combine the top. You have to have what? I'm done. Because we have two fractions. We have x plus 1 over 3 plus 1 over 1. So 1 over 1 can be written as 3 over 3. 3 divided by 3 is also 1, so that's that. Now that I have a common denominator on top, I just worry about what's above this. So I have x plus 1 plus 3. That's the bottom. On tops, as I don't need parentheses since there are only positives, no coefficients, I combine like terms. X 1 plus 3 is 4. Now, we have a fraction over a fraction. Remember, the bottom is also 3 over 1. To simplify that one, take the top fraction, leave it alone. Take the top fraction, leave it alone. Multiply by the flip of the bottom. So it's 3 over 1. I flip it and multiply to it. When you multiply fractions, before you do anything, can anything cancel on top? No. There's no x plus 4 on the bottom. One's just a 1. So I'll multiply top by top. X plus 4 times 1 is x plus 4. 3 times 3 is 9. So my solution to this equation is x plus 4 over 9. So those are the Fogg and Goff examples, and Fogg, Boff, Gog. Now let's look at the examples from our sheet. Now, for those of you who haven't picked up a packet, there's a packet for this stuff in the back of the room, as always. Example 1 says f of x is 2x minus 5. G of x is x squared minus 3x plus 8. A, find Fogg and Goff. Remember, Fogg is f of g of x, and Goff is g of f of x. So the first one, I take my g function, which is this, and I put that anywhere I see an x in the f function. So it's 2 times x squared minus 3x plus 8 minus 5. That's how Fogg works. Get rid of the parentheses, distribute. So we have 2x squared minus 6x plus 16. Whenever you get rid of parentheses, first thing you do is combine like terms. So we have 2x squared minus 6. 16 minus 5 is positive 11. So there's your answer. Now the other one. It says anywhere I see an f function. Anywhere I see an f function. That, I mean, in the g, anywhere I see an x, I put the f function. So I take this equation, everywhere I see an x, I put my function of f. So it's x squared, so it's 2x minus 5 squared minus 3 times 2x minus 5 plus 8. What do we do first? We have to do this x squared first, the FOIL method. So that one, 2x minus 5 squared, is 2x minus 5 times 2x minus 5. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2 is negative 10x. Negative 5 is positive 25. So 4x squared minus 20x plus 25. So that goes in the first spot. So this becomes 4x squared minus 20x plus 25. This next part, I distribute. Negative 3 times positive 2 is negative 6x. Negative is a positive. 3 times 5 is 15 plus 8. I did all three of these steps. Combine like terms. 4x squared. Negative 20x, negative 6x, they're both negatives, so I add the numbers, 26x. Combine like terms, so we have these constants. Positive 25, positive 15, positive 8. So 25 plus 15 is 40, plus 8 is positive 48. So there's my answer for that one. That's question A. Question B, it's asking for the fog and Goff at specific values now. Because now we're going to find specific values. Because we defined what x was. X is 7. So what this is saying is f of g of 7. And this other one is asking for g of f of 7. What does this mean? What does g of 7 mean? Nope. In g, anywhere I see an x, I put a what in its place? I put a 7. So in my g of 7, I do that first. I have 7 squared minus 3 times 7 plus 8. 7 squared is 49. 3 times 7 is 21. 49 minus 21 is 28. Plus 8 is 36. That is just what we put into our other function now. We now have to do f of g of 7 becomes f of 36, which becomes anywhere I see an x in our f function, we put a 36. 2 times 36 minus 5. 36 times 2 is 72. So the answer is 67. So f of g of 7 is 67. So all you have to do here is just find one value and plug that into the other equation piece by piece. Is there another way we could have done it? Yes. What we could have done, since it asked us for fog, up here we did fog. This is f of g at x. All I have to do is I take this equation and I put 7 in place of x. So it tells you you can either do piece by piece, or you can combine them first and then put the value in there. So if I put 7 in place of x, 2 times 7 squared minus 6 times 7 plus 11. 2 times 49 minus 42 plus 11. 98 minus 42 plus 11. 98 minus 42 is 56, plus 11 is 67. Same answer. So you can do whatever's easiest for you. If you like to combine them first, you could do that, or you could first find the value and plug them in from there. So like this one, I could just go straight to this one and plug 7 inside there. Which way you want to do it? You want to do f of 7 first and then find, or just plug them in this one? Okay, since we did this one already, let's just plug it in there. 4 times 7 squared minus 26 times 7 plus 48. Seven squared is 49. 26 times 7. $49 times 4, 36, is 196. 26 times 7 is 182 plus 48. 196 minus 82 is 14. 14 plus 48 is 62. And that one's faster because we already did the work. If we didn't do the work, if we didn't have the work already done, we would have first had to find f of 7. So f of 7 would have been 2 times 7 is 14. 14 minus 5 would be 9. So we would have to find g of 9. What is 9 squared? It's 81. 3 times 9 plus 8. These numbers look a lot easier to deal with. 81 minus 27. 54. 54 plus 8 is 62. You can use whatever method you want to do. I personally like to find the values first and plug them in there. Makes it much easier. C. G of 1. Remember, g of x was x squared minus 3x plus 8. So what this one's asking for is g of 1. So what are we going to do first? Find g of 1. So anywhere I see an x, I put it in 1. 1 squared is 1, minus 3 times 1 is 3, plus 8. 1 plus 8 is 9, minus 3 is 6. So g of 1 is 6. Since g of 1 equals 6, I now have to find g of 6. So anywhere I see any x inside there, I put a 6 in its place. 6 squared, 3 times 6 plus 8. 6 squared is 36. 3 times 6 is 18. Negative 18 plus 8, I can combine those, makes it negative 10. 36 minus 10 is 26. That's my answer. Remember, f was 2x minus 5. What this one's asking for is f of x. So f of x is 2x minus 5. Anywhere I see an x in this equation, I put 2x minus 5. So it becomes 2 times 2x minus 5. So here's my x value. Get rid of the parenthesis. 4x minus 10 minus 5. They're both negative, so I add them. So there's my answer. What do y'all think? It's just numbers you got to make sure you work together. Example 2. F of x equals square root of x. G of x equals x minus 3. So A is f of x and Fog and Goff. We'll find those first, typically. So this is f of g of x. This is g of f of x. So the first one says, I take my equation g, anywhere I see an x in the first one, I plug it in there. What's the domain of this one? Right. Because we can only have a 0 inside there, so we set that equal to 0. So the smallest x we can use is 3. And this other one, anywhere I see an x in the g, I put an f. So it's square root of x minus 3. What's the domain of that one? Right. Because yeah, we just have that. That's the only restriction we have. the decomposition of functions, which means take them apart. H of x is our function. It equals 2x minus 3 to the fifth. Find f of x and g of x so that h of x is equal to fog. So what does fog mean? That means f of g of x. Why is that important? Because g of x is the inside function. So in this equation, what's the inside function? 2x minus 3. Because that's inside. It's inside what? The outside function is x to the fifth. That's what this is looking for. What is the inside function? What is the outside function? H of x is equal to 1 over x plus 3 cubed, where h of x is equal to fog, which means f of g of x. Find f of x and g of x. So basically what this is asking, when we're asking for the inside function, it's the part of the equation you would do first. So it's the first thing you would work on. Inside the parentheses. That's the g of x. X plus 3. That's the inside function.
Does the parentheses give it away?
Usually. Yes. Like the last example, the parentheses, because that says I'm encapsulated in this. So there you have it. Yes. So what would be my f of x? What's the outer function? Right. Because this is my variable. It's cubed. So far, so good? Good. Because that does it for that section. And that individual chapter. Let's see how we can use this stuff now.